All right, let's talk about Python objects, but not just any objects. I'm talking about your custom classes. We're going to figure out how to take them from, just okay, to being as smart and powerful as the built-in types we all use and love every single day. I mean, have you ever really stopped to think about why Python's built-in types are so, well, smart? You take a list, you wrap it in len, and boom, you get the size. You print a dictionary, and you get this beautiful, readable output. It's just so seamless, right? Everything works exactly the way you'd think it should. And then you go and make your own class. And suddenly, all that seamless magic is just gone. You try to print your object, and what do you get? Some weird, cryptic memory address. You compare two objects that you know are identical in value, and Python tells you, nope, not the same. It feels so clunky, doesn't it? Almost like taking a huge step backward.
Okay, but what if I told you there's a secret to all this? A way to teach your own objects how to play by Python's rules. That's what we're doing today. We are going to give your objects some superpowers. Real superpowers that let them hook right into the core of the language and act just as cool as the built-ins.
So, here's the game plan. First, we'll nail down the problem. Then, we'll unlock the magic. We'll give our objects superpowers for better representation, smarter comparison, and even custom truthiness. And by the end, you'll see how this all leads to writing way more Pythonic code.
All right, let's get into it. Section 1, the problem. Because, to really appreciate the solution, you've got to feel the pain first. So let's talk about why our custom objects feel so, well, basic, right out of the box.
So picture this. You create a simple product class. It's got a name, an ID, a price, pretty standard stuff. You create an instance of it, and you're feeling good. Then you try to print it to see what's inside, and you get this gobbledygook. I mean, sure, it tells me it's a product object and where it is in memory, but that tells me absolutely nothing about the actual product. It's totally useless for debugging, right? So how do we fix this? Well, the solution lies in what a lot of people call Python's magic. But here's the thing, it's not magic at all. It's actually a well-defined protocol, a framework that lets us hook into the language itself. It's called the Python data model. And the best way to think about it? It's like a secret instruction manual for your objects. And this manual isn't written in English. It's written using these special methods. You've seen them before. They're the ones with double underscores at the beginning and end. We call them Dunder methods for double underscore. When you write a method like underscore init, or, as we'll see, underscore string, you're not just adding a function to your class. No, you're doing something much more fundamental. You are telling Python itself how your object should behave during core operations like being created or printed. Okay, time for our first superpower, better representation. We're going to give our objects a voice so they can stop mumbling that memory address and actually tell us who they are.
And just look at the difference. It's night and day. On the left, we've got that useless default output we saw before. But on the right, after we add one simple Dunder method, underscore string, printing the exact same object gives us this beautiful, clean, human-readable summary. We've literally taught our object how to introduce itself properly. So much better.
Now here's where it gets interesting. There aren't just one, but two methods for this. We have underscore string, which is all about creating a nice readable output for the end user. But we also have underscore repr, short for representation. Its job is different. It's meant for developers. The goal of underscore repr is to be an unambiguous, official string that, ideally, you could copy and paste back into your code to recreate the object. So, easy way to remember. Underscore string is for users, and underscore repr is for us.
And this is a super important tip. If you only have time to implement one of them, always choose underscore rep. Why? Because Python has a fallback system. If it looks for a underscore string method and can't find one, it'll use underscore rep instead. So a good underscore rep acts like a safety net, guaranteeing your object always has at least a decent, developer-friendly representation.
All right, superpower number 2, smarter comparison. It's time to fix Python's default and, frankly, unhelpful idea of what it means for two of your objects to be the same.
Okay, look at this. You create two rectangle objects. They both have a width of 10 and a height of 20. Logically, they're the same, right? You'd expect them to be equal. But when you ask Python, it says false. And that's because by default, Python isn't comparing their values, it's comparing their identity. It's asking, are these two variables pointing to the exact same spot in memory, not do these two rectangles have the same dimensions?
But of course, we can fix this. We can take control by implementing the __EQ__Dunder method. Inside this method, we get to tell Python exactly what it means for two rectangles to be equal. In this case, it means their width and height have to match. And once we do that, bam! The comparison works exactly the way you'd expect. True!
Now this part is super important. When you define equality, you're entering into a contract with Python. If you want your objects to work in things like sets or as dictionary keys, you must also implement the __hash___ method. The rule is simple, but it's unbreakable. If two objects are equal according to your __eq___ method, then their hash values absolutely must be equal too. This is the secret to making your objects play nice with some of Python's most powerful data structures.
And for our final superpower today, we're talking about truthiness. You know, what happens when you put one of your objects in an if statement? Does it count as true or false? Because the default behavior here can be the source of some really sneaky bugs.
Here's the problem. By default, an instance of a class you create is always considered true. Always. Now imagine you've built a custom queue class. You'd naturally expect that an empty queue would be falsy, right? So you write if my_empty queue, expecting that code not to run. But by default, it's true, and your code runs when it shouldn't. That's a nasty bug waiting to happen.
And the fix is super easy. You can implement the _bool method where you just explicitly return true or false based on your object's state. Or, even better, if your object is some kind of container, you can just implement _len. Because just like with rep and stir, Python has a fallback here too. If it can't find _bool, it'll look for _len and automatically consider your object false if its length is 0. With one tiny method, your custom containers start behaving just like Python's built-in lists and dicts.
Okay, so let's put this all together. Why do we even care about all this? Look, mastering these Dunder methods is so much more than just learning a few neat party tricks. It's about a fundamental shift in how you approach writing Python. It's about learning to work with the language, not fight against it.
When you start using the Python data model, your code just gets better. It becomes more intuitive for you and for anyone else who has to read it. It becomes more readable because it acts in predictable ways. It's more robust because you've thought about these core behaviors. In a word, your code becomes more Pythonic. It stops feeling like this weird custom thing you bolted on and starts feeling like a natural, integrated part of the language.
And honestly, we've only just scratched the surface today. We covered representation, comparison, and truthiness, but the data model lets you customize everything. You can teach your objects how to do math with _add_. You can make them iterable with _getItem_. There's a whole world of power just waiting for you in those Dunder methods. So the real question is, what superpower are you going to give your objects next?